We'll get going here in just a bit. I'll say hi to folks. Sorry for the air conditioner noise, but I will not be able to do 2 hours if I don't have the air conditioner on. How's everyone doing? Let me check the YouTubes. Restream is going. YouTube is going. Hello, everybody. I hope you're having a good Friday. I've been a little distracted, but I am making slow and steady progress. More Matter matters today. Yes, Tyeth. Hello. Thanks for joining. Yes, my plan is to work on more Matter stuff. I keep finding layers. Although I'm trying to dig myself back to the where I can send a message back, and like, I think that'll be a pretty big deal. Hamzab says, I hope all is well with you and yours. It is. Thank you. Hello, David. And the YouTube chats. I'll wait just a little bit longer. Do 2 minutes. How's everybody doing? Staying cool if you're in the northern hemisphere, I hope. I don't know how the weather is in the southern hemisphere. All right, let's get going. Okay, hello everybody. My name is Scott. I work for Adafruit. Adafruit is an open source hardware and software company based out of New York City. You may have noticed because you're on their channel. I work for them remotely. I work out of Seattle. And I've worked on CircuitPython for that time since I joined them almost 8 years ago now, 2016, I think. It's like 8 years in a month or so, something like that. So CircuitPython is a version of Python designed for little microcontrollers. Microcontrollers are little tiny computers, come on boards like this. This is not made by Adafruit, but I do believe we sell some of these. This is the an Espressif dev kit for their ESP chips. They're usually Wi-Fi connected and sometimes BLE and sometimes Thread as well. So Adafruit, they're in the business of teaching you how to use electronics to do all sorts of different projects. And CircuitPython fits into there by being the easy way to program them to do what you want. Although Whippersnapper is giving us a run for our money in terms of ease of use, which is awesome. It's good to go that way. So if you want to support me, you can support Adafruit by going to adafruit.com, purchasing hardware there. Note, and I know this is on the website, but all orders from Adafruit HQ themselves are delayed because they are actually moving Adafruit HQ. If you want to get an order and support Adafruit sooner, I recommend a reseller such as DigiKey. Adafruit doesn't get as big of a cut, but they still do get a cut. If you want to join the Discord chat, the middle one here is Discord, which is a chat service that is around all the time. You can do that by going to the URL adafru.it/discord. This is a deep dive. They tend to be about 2 hours, 2 to 4 Pacific here on Fridays. If I'm not able to do it, Tim, aka Foamy Guy, usually fills in. Does a great job. Thanks to Tim as always for doing that. Yeah, so this is a deep dive. It's 2 hours of technical content. My hope is that if I lose people, they'll ask questions about what I'm doing, and that'll give me the, like, hey, you need to take a step back and explain what you're doing. So I'm happy to answer questions about any sort of thing. My game plan for today is to continue working on implementing Matter, which is an IoT spec in pure Python. It's a big task. It's a big task, and it's like follow the specification sheet and try to just implement it as I say. So that is kind of the main thing I was gonna do. Are there any questions before I get started with that? Any topics that folks want to cover? Otherwise, I can keep working on what I've been working on. All right, I don't see anything. So the main thing that I've been working on is we want to support the Matter protocol, which is a protocol that lives kind of above IPv6. So TCP and UDP as you would expect, but the addressing is through IPv6 and not IPv4. And the goal is to be able to like make a CircuitPython device is just like a light bulb. It's like kind of ridiculous, but the Matter specification is designed for like you buy something off the internet that's a light bulb, and you need to securely commission that onto your network. So you need to make sure that the device is certified and is actually like the device you think it is. It hasn't been tampered with. You need to get on your network securely, and then all of the communications to that device need to be secure as well. So there's a lot of layers. I think for so far good reason. It's just like it's a lot that goes on under the hood in order to do it well. You know, there's this running joke that there's no S in IoT, there's no security in IoT, and one of the things that the Matter spec has been trying to do is to bring the S to the IoT, bring security to IoT devices. So I think that's why there's a lot of these layers, is to try to mitigate security vulnerabilities, which is interesting because with CircuitPython, if you have access to the device, the goal is that you have really easy access to the code, which is actually not something that Matter is designed for. Matter is designed for verifying, like downloading code off the internet from the manufacturer and verifying that it's legitimate. It kind of like it doesn't really, there's a couple places in the spec where they talk about homebrew or hobbyist use, but generally that's not their goal. Their goal is like, I'm going to make a light bulb with an ESP in it, and I'm going to sell 1 million of them and keep track of all sorts of things and make sure that like nobody is able to load firmware on there that actually is a botnet or something like that. So there's a lot of complexity underneath the light bulb, a lot around that, like security stuff. So that's where a lot of the complexity is coming from. And they also want it to like just kind of work, which is also a challenge. So it's been interesting to see them. Oh, there's a fire truck going by. Got distracted by the fire truck. That spec is thick. Yes, it is. It is, but I've been stuck in a single chapter so far. Like I read more of it, but my approach, and I think I was asked about approach last week, but it's generally just like learn it as I go, learn it as I need to. So I figured out how to get, so I have, and maybe I should cover this first, is that there's like usually kind of a device that's tasked with like managing all of the other Matter devices in your home. And that's usually, to me, and hello CareString. I have it, I want to say thank you. I should say thank you to CareString right now. So let's go to the desktop, and you'll notice here that I've got this pull request open from CareString that is they were talking about using Hypothesis for testing, and so they added that support and tweaked the CircuitMatter stuff there as well. So thanks a lot for working on this. It's awesome to see people interested and following along. I appreciate like bringing almost more Python knowledge to it than I do, especially on the unit testing side. I was using unit testing for a while to really make myself feel like I'm making progress, and I'll give you an update on where I'm at too. But let's talk a little bit more Matter first. Evehome. So evehome is a popular but kind of pricey IoT brand, but they have this pretty good reference. So you generally need a controller, and they're showing you kind of differences between a Matter controller and a thread border router. So what I'm targeting right now is just kind of like Matter over Wi-Fi. So I'm not worried about thread right now. But there's also this thing as a thread border router, which is a bridge between kind of your local Wi-Fi network and a thread network. Thread is like a low power mesh wireless networking protocol, but you do IPv6 stuff on top of that protocol. So the bridge is its job is to present a kind of uniform IPv6 landscape, even if some of the devices are connected over thread instead of over Wi-Fi. So generally, you need a Matter controller, and if you're going to buy one because you want to do this, you definitely want to get one with the thread border router functionality. And so the ones I kind of recommend are the Nest Hub 2nd Gen, which I have at home, and I have a HomePod Mini. So when I'm doing my testing here, it's the HomePod Mini that is trying to talk to me. Is it like LoRaWAN? Oh no, it's indoors, of course. I don't know a lot about radio stuff, but it uses the same underlying radio as Zigbee does. So it's a different protocol, but like the radio packets are similar to Zigbee. And a lot of this Matter stuff comes out of the folks that did the Zigbee spec. So like the CSA, and I forget what it stands for, like the people that made the Matter spec, they used to be called like the Zigbee Alliance. And then they renamed themselves. So we're not doing Zigbee, but we are doing like something that has its origins. Probably a lot of the same people did that. So when I'm talking to another device, or another device is talking to me, it's my HomePod Mini that is the term for controller. So controller is like the thing that is managing all of the devices on the network. So if you want to join what's known as a fabric, if you want to kind of join into this encrypted world of a Matter network or fabric, you have to talk to the controller to get commissioned. So commissioning is the process of saying, hey, I want to join your fabric, and let's negotiate how to do security, and you can verify with me that like you should allow me on it, and blah 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 blah. So when I'm doing my testing here, I'm using my HomePod Mini, which is right over there by my microwave. And specifically, and also I'm not targeting this for CircuitPython. So like one thing that makes me feel like I can get to the point where I can be a light bulb is I'm like ignoring some of the stuff. Like I'm not worried about being a bridge. I'm not worried about being a border router. I'm not worried about being a controller. All I want to be is a Matter device that can get onto an existing Matter network and talk to other devices on it and be talked to, so that I can so this says works with Apple Home. So on my phone, I pull up my Apple Home device, which is talking to my HomePod Mini, and then my HomePod Mini is doing the management. Just something funny, I'm also watching the Cubs Razorbacks game, and there's been a pigeon along the third base line for an hour now. Pigeon must like baseball. I think that's baseball, right? Razorbacks. I went to one Mariners game this year. I used to be really into it when I used to be into Legos. Legos have made a comeback. Mariners baseball has not in my sphere. And you can see here that there are devices here that are Matter controllers but are not thread border routers. So it would work right now. These would also work with what I'm targeting, which is I'm targeting Wi-Fi Matter. So those would work with that, but it wouldn't work with a device that was trying to do thread, which is a lower power protocol. But we're not doing that first. Although I think I saw Rye was in the chat too, and they were gonna. I think Rye was the person looking into adding thread support. So that's kind of cool. Is like we could start to segment out who's working on what. So I'm doing IPv6 up, and if you followed along, Jeff Epler, who works on CircuitPython core, is doing IPv6 down, kind of into the networking Wi-Fi stack to make sure that that all works. Joey Jojo Shabadu, trying to build a scoreboard according to spec using the Adafruit Matrix Portal S3, downloaded package and getting syntax errors all over the place. First error is not finding the Wi-Fi module. That's likely that you're using the Python on your computer rather than CircuitPython. So let us know what IDE you're doing, and we could probably help you get in the right mode. Usually there's a mode where you can switch from like desktop Python mode to CircuitPython mode. But it's common. So Wi-Fi, for example, is a built-in module in CircuitPython. So you'll likely not have that working if you're accidentally using native Python. So I'm actually targeting native Python first. I'm doing the development locally. And so let me give you an update on what I've been doing. So last week, let's just look at the code. Last week, I was doing TLV, I think. I hardly remember. What was I doing last week in deep dive? How far had I gotten? I've been trying to do just like a little bit reliably every day. So TLV is this encoding format for kind of like the lowest level or like the second lowest level of packets. There's a couple other encoding layers there that I actually need to work on today, I think. But for the actual kind of like initialization of things, where the data like varies a lot, it's in these TLV structures. TLV stands for tag length value. So there's a control byte, and then there's maybe there's a tag, and maybe there's a length, and then there's a value. So that's kind of why it's called that. And I did a lot of the testing there on that, and this is what CareString was actually helping with as well, which is doing this TLV encoding. So I feel pretty confident that we're actually encoding and decoding TLV packets well now, which is great because they are foundational to. They're pretty foundational. You're always going to use it in some form when you're doing Matter, so it's like definitely something we need to do. I don't remember when I added this, but I think I did it earlier this week. So I'm kind of working right now between TLV and the wire, or the raw packets. So one of the main things that is in, actually let me pull up the spec. So one of the main things, well, like I said, I'm mainly in this secure channel 4. So chapter 4, this is how you go from an unencrypted messaging to secure messaging. And unencrypted, and so the very first packet, so what I'm doing is I'm starting up my script, I'm going into my phone, I'm selecting the device that it discovers. That is done over MDNS, which is multicast DNS. Last week I was doing TLV decoding. Oh, great. So I've done TLV encoding. Maybe I have made progress. Well, I've been pretty distracted by Lego, but I think I have made good progress too. So maybe, let me just show you. Maybe I should just show it. That's a little bit of a spoiler. Okay, so I'm gonna run my CircuitMatter thing, and then I'm going to pull up Apple Home. So on here, I can go plus, add accessory. I'm not going to do the QR code right now. I'm going to say Matter accessory. I'm going to type in some random setup code, which I haven't even gotten to the point where we verify it. I'm going to hit continue. And now you'll see I crashed. Oops. But one thing that's cool that I added just yesterday, so I'm just going to hit exit setup here, and it's going to stop trying. But one thing I did is I added packet recording. So when I do this kind of live testing, I'm also recording all the packets that I get in. I'm also going to record the ones I send, but what I can do is this other thing where I'm running the same thing, but I'm giving it the file that it records the packets to. So now I can rerun my script with the data I just got and get the same error, but not having to actually do like not actually having to do the phone side. It's just reproducing what I just did, which I think is going to be really helpful for what we're doing. Show us the Lego too. A lot of the Legos at home, but I did get a box of bulk Lego from Goodwill, which is like a thrift shop around here. So I did get that. It's very dirty. But one project that I want to do that I've been thinking about is a Lego sorter. Snapshot testing, yes. DCD says clever recording and playback. Thank you. It's also good, like in theory, you could use it for integration tests and stuff too. But it actually made me very happy. So one difference that CircuitPython has from CPython is that we actually have socketpool. So socketpool is this weird thing where it's an object that acts like a module in CPython. So you create a socketpool and then you use it like the socket module in CPython. But the nice thing about it is that the nice thing about socketpool is that it's not a global. So you're forced to kind of like pass it around, whereas with socket, you just import socket and you can use it. But the nice thing, if you're forced to pass it around, you can replace it with other things. So the way that this replay stuff is doing, hi Dean, welcome. We're working on the low-level bits of the Matter IoT protocol, which is like a home standard. So here's what I did is I've restructured main a bit. So I say, oh, hey, if you give me a replay file, pass it into this run. If I have a replay file, I'm just going to make a replay socket pool and a dummy MDNS, and I'm not going to record the packets because I already have the packets recorded. And then I pass both the socket pool and the MDNS server into my CircuitMatter kind of high-level process thing. And I'm still trying to figure out exactly how to structure, like, how do you process packets, but my idea right now is that you just, like, in a while loop, you call process packets. And I also give it device state, so you actually need, like, long-lived data. And so I'm just going to throw it in a JSON file. And then record file would be empty. So this is how I'm doing replay, is that I'm either giving it real socket and a real MDNS server and then recording the packets, or I'm giving it a replay socket pool and a dummy MDNS, and then no file to record to. And that the benefit, this is where socket pool is really nice, is that you can hand it something else. You don't have code that is saying import socket, and you have to like patch what that import socket means. Instead, you actually like properly pass it around. We can look at the recorded file. So if we look in test data, recorded packets is here, and I'm just getting, this is the very first packet that I'm getting. So I'm just saying, oh, I received something. This is time, Unix time maybe? I don't even remember. This is the IPv6 address it's coming from. And then this is just base 64 encoded the bytes that I got from the socket. So in main, for my replay socket server, I have to stub out like, oh, if you want to get a socket, I'll just give you a replay socket, and if I've already created it, I'll just complain, just to double check. And then I give the replay data here. Binds doesn't actually do anything. Set blocking doesn't do anything except print. And then you look through your replay data until you find one that says it was a received packet, and then you decode it, and you return it as you would if you were, well, you receive it into the buffer. So you copy it into the buffer you have, and then return the address. CircuitMatter is a great name for it. It wasn't my idea. And it's a little weird in my fingers because now I have to like decide what, I can't just type CircuitPython. I have to say Matter, not Python. But yeah. Okay, so what I've done is I've gone from this world of like using unit testing to verify that I'm like working in the right direction, and Rai says my OpenThread module is added, but I'm having trouble getting the IDF OpenThread component added. Check in CircuitPython dev and we can help with that too. So one thing that I did do is, if we look at I'm in chapter 4, and they have this whole thing about message counters. And the reason that they have this thing about message counters is that, well, we have message counters to like detect duplicate messages and acknowledge messages. So they have this reliability layer that sits on top of UDP, which is like, UDP is known for not being reliable. But I think some people think there's probably too much overhead to TCP. So this is like trying to be between UDP and TCP. Encryption nonce that ensures each message is encrypted in a unique manner. Replay prevention. So one of these fundamental kind of primitives like TLV is this message counter stuff. And if you look, so this is the frame format. So this is like the very outer layer of the packet. You can kind of think of as like, you start at the beginning and you get an idea of like the wrapping, the onions of the packet, the like layers of the onion for the packet wrapping. So the first layer, and this layer is unencrypted, so this is the one that you can read straight off the wire all the time, is message flags, session ID, security flags, message counter, source node ID, destination node ID, and then you have a message payload, but note it's likely encrypted. The message payload is encrypted. Optional footer, which I have not run into yet, because it's probably for, I don't know what it's used. I don't do it yet. Sorry. So then within this message payload is a protocol header, which has exchange flags, a protocol opcode, exchange ID, protocol ID. So it was interesting. I was talking to a friend about this, and he's like, you know, they have this reliability protocol, but does that mean that you have to like guarantee ordering? And I think the answer is no, because you're kind of like, there's this notion of an exchange, and exchanges can only have one pending thing at a time. So you can potentially have multiple exchanges going on and get exchange data out of order between the different exchanges, but within a single exchange, you can only have one thing going at a time. You have to wait for the reply and stuff. So I think that's why like at the lower levels of like this message reliability, you're not actually worried about ordering. It's because you have these constraints about like for every given exchange, you can only have one pending thing, which is something I'm like just starting to dig into and figure out. So for a while I've been parsing this. So that I started by parsing these headers. And then this application payload here is the thing that's TLV encoded, usually, well, as far as I've seen so far. So I was like, okay, I've got this packet. Let me figure out what's in the packet. Now I constructed an object for the response. And now I want to encode the response, the TLV encoding. So I've done that. And now I want to wrap it back up in a protocol header, and then I want to wrap that protocol header stuff in a message header, and I want to send it back. And so I'm to the point where I'm trying to figure out the outer level message decoding and encoding rather than the lower level or the inner level TLV encoding and decoding. Does that make any sense? Clear as mud? Any questions? It won't be much different than the current naming conventions like CircuitPython, Adafruit CircuitPython requests. Yeah, one thing we looked at was like PyMatter, but there's this other chat service called like Mattermost. So there's like a lot of things that are kind of like existing Python libraries that are circled around the other Matter meaning. Carestring says, it does to me, but I've read a bit of the spec when I tried to understand the TLV code. Great. Well, I appreciate your help looking at this. Are you hoping to use Matter, Carestring? Is that why you're getting excited about this or working on it? Okay, so let's take a look at one thing I like to do, and I'm happy that I'm no longer in unit test land. I'm grounding myself in this, like, okay, I'm actually gonna run it on live packets. And oh, I don't want to have to do it on live packets every time, so I'll add this recording mechanic. And one thing is when I have trouble focusing, like my brain's stuck on watching Legos or something, perhaps, it's really nice to have this, like, okay, here's an error, and all I need to do is fix it, right? Like that just like gets me kind of like. There's this book I've been reading with my son where like the bear steps onto an escalator and just gets taken away with it, and like fixing errors like this is kind of like that, like just step on it and you'll get into it sort of thing. So like I said, I've been trying to figure out how to wrap the payload back into message objects, and I've just switched to how I want to do it. So now I want, I think I was looking for the common pattern for structuring a Python object where you kind of like are doing this like decode it from this blob, encode it back to a blob sort of thing. And what I've settled on is in the constructor, you don't actually do anything, you just clear it all. And then what you can do is on that object you call decode, and it like fills it in. Or you say, I did encode into because I would like you to provide the buffer just so that we don't have to reallocate it if we don't want to. It's really easy to wrap an encode into encode, where you just like you allocate a buffer and then call encode into and then return that buffer. This is a better practice for like not using quite as much memory. And I'm seeing my thing complain, and I'm not gonna call send. I'm also trying to do this like as late. I'd like to do this encoding as late as possible. So that we have kind of all the data we need and we just do it into one packet and we're done. So to fix my test, and I haven't written unit tests for this, I'm like, the consequences, I'm out of that land. Oh, I moved a lot of the logic into a top-level CircuitMatter class. You can see I've started playing around with like loading the state file, packet buffer. So here's a packet buffer where, would Matter have MQTT support, or does it have its own protocol for that kind of thing? I know nothing about Matter. So Matter is, you could bridge Matter to MQTT, but it's different. I don't know all that much about MQTT myself, actually. But a lot of what Matter is doing is, well, it does a lot of things. What the layers I'm in right now is like discovering devices and talking to them stuff, but they do also define like, here's the API for talking to a light bulb, and that's something I imagine, like MQTT doesn't really do that. Yeah, I don't know enough but they're kind of different. Theoretically, you could do MQTT over like IPv6. I think it would they would be like peer protocols, not one on top of the other. Okay, so here's how to start commissioning, and I've abstracted out, like in here before I had a direct call to like subprocess, and now I've factored it out, kind of prototyping in my brain how we'll expand the CircuitPython MDNS implementation to be able to do everything that we need for this. But in the right now we don't need to do that. So now I have this process packets loop where it's reading from the socket. If there's no more packets, it breaks and then returns. If we want to record packets, it just appends it to our list, and then calls process packet. And then when the object's deleted, it dumps the recorded packets to the file. It also shuts down a thing that doesn't exist anymore. I don't think it, oh yeah, this doesn't need to be there. That was left over from when MDNS was abstracted out. Okay, so there's this kind of like, okay, here's a packet, process it. So first thing we do is put it in a message, but what we can actually do now is we do message.decode data. And then I'm trying to figure out like, okay, how do I, okay, so we take a message, we decode the data. If it's a secure session, we'll decrypt the payload, but we haven't gotten that far yet, so I'm just skipping it. We parse the protocol header, so that is encrypted, therefore we have to decrypt first. And then we do this process for marking duplicates, which is surprisingly complicated. So marking duplicates just can tell you if the packet we've received in is actually one that we've already gotten before. And then we process the exchange. So there's this additional notion of, Some Nice says, I had to go with Matter and struggled, so if CircuitMatter helps, I'm on board. What did you try to do with Matter, and what did you use? Did you use ESP Matter? What do you want to use Matter for? Tell me what your uses for Matter are, and because I'm not gonna implement the full spec. Although I suspect that ran into issue not having the thread border router. Yeah, I'm not gonna help you with that right now. There's actually a Espressif dev kit for doing a thread border router. You actually need 2 Espressif chips, which is kind of wild to me that you need that. Like, I think both the S3 and the C6 can do both Wi-Fi and thread, so I don't know why there's not. Maybe it's just that you need your radio always active or something. But yeah, for the first go on this, it's going to be like you just need, if you want to do Matter over thread, then you're going to need a separate thread border router. Oh, you know what? I think I did read this. Let's see what you say. 6 flavors of smart light bulbs. Bought the SparkFun board. Use the Scilab's IDE. Vendor IDs, product IDs, authentication, command line contouring, and QR code scanning. Ah, original Google Home. I was thinking about all the QR code authenticity stuff. I kind of was planning on implementing all of that in Python so that, like, the first time you make the CircuitMatter object, it just generates all that stuff for you and dumps it on your drive. There is like a test certificate that you can sign with. Yeah, so I went that route a little bit. But yeah, there's a reason I'm re-implementing is I had quite a difficult time with like the C++ implementation as well. So I feel ya. I feel ya. QR stuff would be should be easier. Got caught in a loop. ESP border router works well with Home Assistant and the Scilab's Arduino core. Nice. Do they have an Arduino API for Matter now? I don't actually follow Arduino land at all. Okay, so let's see if we get past this error. We should. And then a clear message object has no attribute protocol opcode. So I'm trying to set it. So I must not have just... this file's getting a little bit large, and I'm probably going to want to split it apart. But... I'll be able to set up an ESP32S3 to communicate to an Echo Show and stuff like that. That would be cool. Yeah, so the pitch is that you'll be able to interoperate with any commercial devices that are Matter capable. They should warn you that it's a test device or it's an uncertified device, but it still should work. I'll have to look at the Easy Matter library. But yeah, so commissioning is the process of telling like your Echo Show or your HomePod Mini about the device so that it shows up in your like big company IoT ecosystem thing. Okay, let's fix that error and keep going. Okay, so this is what happens when the replay is done. So we did successfully parse it now, and now we're getting to the point where it's trying to receive another packet. There's some printing going on. I think what I want to get to the point today, looking at the time, I have just over an hour. I think my goal should be to, in this CircuitMatter, maybe this is too not ambitious enough, but I've got this construct a response. I have a particular exchange that I'm doing it within. So pass in protocol opcode and the encoded response. I wonder if I should... I was thinking about whether I want to lazy encode it or encode it early. I could always change it. But I think what I should try to do is get to the point where I'm... Taya says, is there some community group for getting certificates for indie dev devices? Still signed rather than test device signed. I thought one needed devices certified before some bit of the process. ESP Rainmaker effectively handled that for you, but also allowed you a bit of flexibility with the signing pathway. So the only way that I know is to use tests. So if you look in the spec, and you search for hobby, there's one reference to it. It says the test vendor IDs are reserved for test and development by device manufacturers or hobbyists. Okay, so the VID that we're going to use is 3 of these, FFF1, 2, 3, or 4. So you do that, and it says commissioners, which is like what my HomePod Mini is, should not commission devices using one of these VIDs onto an operational fabric under normal operations unless the user is made fully aware of the security risks of providing an uncertified device with operational and networking credentials. So I took a screenshot of it. I did get one of my ESP boards working as a test device, and maybe I should just find it. Let me just show you. I took a screenshot of it. I got the like, hey, are you sure you want to do this prompt when I was playing around with it. How far down is it? I've been working on this a while and also doing a lot of Lego stuff. I'm most of the way through the up house. Okay, here we go. So I could pull it up actually on Google Photos too. But so this is what my phone said. Oh, let me switch. I'll switch to the full camera so you can see it better. So this is the screenshot of me. It says, hey, this is an uncertified accessory. Do you want to add it anyway? So that's, and I'm totally fine with that. And here I'm trying to hit cancel on the screenshot. TJ Devon3 says, I remember the screenshot in vendor ID said unknown or something like that. Could you enter Adafruit or custom vendor? I meant to play with that a little bit. I do think I'll be able to have it change what it shows. I do think I'll be able to change what it shows. I'm not positive. I worried it would be a bit like installing untrusted apps, a few hoops for users to do where they can see/install, unless technologically capable users would struggle. So I think that the like scan the QR code or type in the setup code on the box thing is the same. This prompt is after that step. So you don't have to find a place to like enable it. I think you can just say like, I want to commission this, and it's like, hey, are you sure? Which is really not too bad. The only other mention I've seen of this is that they talk about homebrew device development, which I would also say that we fall under. And let me go back to the desktop. So I searched for homebrew, and this is talking about the commissioning process. Upon failure of the procedure, the commissioner should warn the user that the commissionee is not a fully trusted device and may, hopefully everyone does, give the user the choice to authorize or deny the commissioning. Such a warning enables user choice in commissionee trust on their fabric for development workflows as well as homebrew device development. Such a warning should contain as much information as the commissioner can provide about the commissionee and should be adapted to the reason of the failure. For example, by being different between the case of an expired certificate versus a revoked PAI certificate. Certification was something I was not aware of. Even the Arduino Nano Matter can only be ever used as a light bulb, otherwise it's uncertified. Yeah, I believe that. So like the point of certification is that you're like certifying the software is the same too. So there's another place that I saw this, but if you're using like the test VIDs, you can't do over-the-air updates, which is totally fine for us because we're not secure firmware. We're running Python code that you can plug into your computer and change. And in fact, I think Jeff got the web workflow working over IPv6. So like, there's a world I think where you could get the web workflow working over thread because it's all just IPv6, which would be cool too. So I'm not targeting being a certified device. I'm So I had to remind myself of that when I was reading some of the like random cryptographic or secure random number generator stuff. I was like, no, I'll call OSU random. I know it's like not, it's probably even more randomness than we need, but I'm calling OSU random for random stuff. I know I've been skipping around. I also did this like message reception state. So this is you get a message in, and how do you figure out whether it's a duplicate, which is actually helpful for this early in the process, because if I actually just run this again, where it, I fixed some of the initial stuff from refactoring, and I go and I add the accessory. I gotta figure out how to make the QR code work, because that would actually be handy. But what we'll see is I actually have it successfully dropping messages now. So it's like spinning on my phone, waiting to talk to it. And so it's gonna do some, like, I'm really trying to talk to you sort of thing. And that's this message counter that's in that like hour to level message packet. It's that, but it also depends on what kind of session it is. So we can see it's like trying stuff. And I'll just cancel it. So now if I exit setup, we'll stop getting packets. If I control C, now you can see that I recorded all of those duplicate packets. So I've also added the ability to detect duplicates and drop them as needed. So it's optional may to show a choice message. Right, so I do actually want to, it would be good to test. I've only tested with my HomePod Mini. It would be good for me to test with Google Home, and Amazon is the other one I was going to think of, but yeah. In my case with Apple, they just prompt. But yeah, I don't know how other manufacturers do it yet. Okay, so, oh great, I got duplicates working. Well, it turns out there's 3 different approaches to duplicate detection around this. It's just insane. It's so complicated. So like, and that's why, let me show you with the unit test. So I have it here, message reception state. So this is just tracking, okay, I got a message in, it's got this number. Is it a duplicate? Am I okay with it? Do I have developer mode on your phone turned on? I don't think so. I'm actually, I am using the iOS 18 beta, but I think I took those screenshots before I switched. I wanted the new Android or the RCS support, so I was like, oh, public beta. I'll do it, because I'm very happy that Apple's actually like modernizing their experience with other devices, even if it's not as much as they could. Thank you to the EU for pushing Apple to be more standard focused. Okay, so basic stuff. So you initialize, the first time you get a message from someone, you initialize the message reception state with the original number, and then we check that the message counter is set. And now when we do process counter, it's going to return true if it's a duplicate and should be dropped. There's a caveat there. It's going to return whether true if it's a duplicate and false if it's a new message count. So numbers before the original number are marked duplicate by default. The existing number you already got is marked as a duplicate. If you move forward in message counter land, so this is 3 more forwards, you are a new value, so you're not a duplicate. If you get 123 again, it's still a duplicate. But it doesn't, you can't just assume that, you can't just keep a max and then assume everything less is a duplicate, because you might get messages out of order accidentally. So there's what they do is they maintain a bit mask window of 32 bits. So you actually track, given your max, you track the max, and then 32 before that, you remember whether you've seen it or not. So here you can see that 124 is not a duplicate, even though we already got 126, and true for 125. And then if we get 124 again, now it's a duplicate. So that's the basic test. Where it gets really tricky is that the behavior varies a little bit based on, so that's common behavior. That's the notion of like your max value and the 32 window before that is common to all the different cases. However, there are different cases. So window wrapping, so if you're going to roll over, so it's defined, I think, as a 32-bit number. It might be 16-bit. It's a 32-bit number because you can see that I'm doing like full 32-bit. So we start with 123 again. We move to the end. Older's okay. Now we move the window kind of to wrap back around. So now we have 32 previous numbers. 16 are at the top of the 32-bit range and 16 are at the bottom. And make sure that we've remembered which ones we saw, and we're okay seeing new ones, even if they're there. So that's testing window wrapping. I just saw this and I was just like, it's so complicated. So, okay, rollover, that makes sense. Well, if you're encrypted, you say, okay, yeah, we roll over, but if you're in the window, older messages are not okay. That's not right. Oh, right. Older messages are not okay. So this is, you established at 123, you go back 32. Those are marked as duplicates by default. But if you go one more than that, it's newer and it's fine. And then we could also say that like process counter 124 is also okay. Now, if there's a mode where you don't roll over, and so that's if you roll over and you're not encrypted. If you don't roll over and you are encrypted, this is used for individual sessions with different devices. Then older messages are not okay, and any previous ones. So this is the kind of like anything that's less than the window location is not okay. So like 0 is not okay here, but you can increment up. And if you're in the window and you haven't been seen before, it's okay. But then if you get to the very top, it just says, we don't roll over. You're actually supposed to like start a new secure session. You're done. And then lastly, this is used for groups, I think. If you have rollover and are encrypted, just like, oh my goodness. So you have the 32 window, but because you're rolling over and you want to have some other window of duplicates, you want to have like more than the 32-bit or a 32, not bit, but 32 entries window. You want more than that. So what this does is it actually takes another 2 to 31, so half the range back behind the window is also marked duplicate. It's insane. And because it's insane, that's why I wrote these tests. So you start at 123, older messages are not okay, and older messages just outside the window are not okay. If you wrapped back even further, you're still not okay. But then if you move forward, you're okay. And that number is the number that you previously didn't, it's now okay. I don't know. It's insane. So this is like another one of those things of like, we need this like foundational machinery that's kind of weird. And so there's a unit test for that. So the duplicate, this drives the duplicate detection. So in init, we have this marked duplicate. Ooh, I'm putting myself to sleep. We have this marked duplicate thing that says, hey, find my session, get the message reception state. If there is none, then we make a new one. Rollover is always false. And then we process the counter. I don't know why this is complaining, but because it thinks session context can be none, and that's because we don't have groups. Just to confirm, the numbers like 123 refer to the messages in your reported session or relative to the beginning of the session. So this has nothing, this is like just for testing. And it actually does specify that if you were to create a new counter, which is this new message counter stuff, this is the outgoing thing, you actually start with a random number. It's the meaning of the non-relative numbers. Is there a good explanation in the... So it just says, all messages contain a 32-bit message counter assigned by the sender of the message. Message counters are assigned sequentially by monotonically increasing the counter value maintained by the sender of the message. But there's not just one counter, there's a lot of different counters. And they have slightly different behavior depending on your context. But so the number doesn't really mean much, but the number does get, the counter number does get used in the reliability part of the reliability part that's built on top of UDP. And because if we look at the frame format, there's a message counter at the very outer level, and then on the inside encrypted level, there's also an acknowledged message counter. So there's additional complicated logic about saying like, and this is scoped to an exchange. So on the inside encrypted payload, you have an exchange ID, and so you have to kind of like route the packet to that particular exchange state. And exchanges can have kind of one, I think it's kind of one packet going each direction. So per exchange, you can say, oh, I got this message in. It wants to make sure it's a reliable message, so it's got this flag that says like, hey, this is a reliable message. What the exchange does is says, hey, like I'm going to reply to them that I got that message, but I may not want to do it immediately. I might actually want to kind of, they call it piggybacking. I might want to wait for like myself to process it and want to reply back. And in that reply, I can say, oh, by the way, I got this previous message of yours. And that's like what piggyback acknowledgement is. But then there's also rules about like, you gotta, So that's why you don't just drop all duplicates, because there's a scenario where the exchange is saying, hey, I'm waiting to reply back to this message, but I actually got that message counter again because it's trying to be reliable. And if you get it a second time, it's marked as a duplicate. You're not going to pass it on, but you just need to reply immediately. Say, oh yeah, I did get it. I'm working on it. And then it's kind of the reverse. So like I'm sending a message, and I got to remember the message I tried to send, because I may have to send it again. And when I have like some timing like suggestions for when I try to send it again. Unless I get another packet in that acknowledges it, blah, blah, blah. Like, I don't know what to think of all this. Like, it makes sense. I understand why they did a lot of it, but it's so complicated. Like, we're building a light bulb. Like, we're building a computer, like, wirelessly controlled light bulb, and I'm like, I'm so many layers deep, I'm not even talking about like an RGB value. So that's why I'm like, oh, it's complicated, but you know, I am making progress. I think I will get to the point where I actually like reply and get to the next message I get to think. Are you using Wireshark or something similar to watch all the traffic, or just using your recordings? I was using Wireshark briefly. So if folks don't know, Wireshark is a program that can capture packets on your network. I used it briefly to understand what MDNS stuff was happening, because MDNS queries are unencrypted on your local network. So I was using Wireshark for that a little bit, and if I do the QR code of what I think it should be discoverable by, it doesn't work. So I do want to Wireshark what my phone is like MDNSing when I do the QR code versus the setup code. But for all of this Python level stuff, the recordings, I just did the recording stuff yesterday. So I haven't done it a ton. I may find that I have more trouble when I get kind of more packets in. But for now, it's working good. Yeah, I'm complaining about this, but CareString says, yeah, but in my previous apartment, my neighbors can control each other's light bulbs, and that's suboptimal. Yeah, it's true. Like, all the security stuff is making sure that you're like, and I've had a couple cases where I've had Bluetooth speakers get randomly play stuff that's not my own. Like I woke up at 3 a.m. one night to like something blaring when I lived in an apartment. Like, yeah, I mean there's reason for it, and that's kind of why I like say bah humbug and still work on it. DCD says, are they trying to solve problems that have been solved in other internet protocols already, or are they trying to solve newly discovered issues? I think it's fair to say that they're trying to solve it in a lighter weight way. All this reliability stuff I feel like they are trying to solve in a lighter weight way than TCP, because imagine a device, like a thread device that's not on very often. Like you're not going to maintain a lot of state and having like things going back and forth. So I don't know. I don't think so. But then again, I don't know other networking stuff that well either. Okay, so we got a better recording. And I want to get to the point where I'm seeing dropped message, but I'm not. Am I actually trying to respond? So in Exchange, there's send standalone. And I think I want to think what I'll do is I'll say, so I think I don't think I want to do the packing here. Did I already move it? Decode, encode into, yeah, I already moved it. So I can delete, this is what I was doing last. So this is the kind of like the piggyback of like, hey, we're sending a thing, and oh look, we have a pending acknowledgement. Are you using pywrite as an LSP? Yes. I've got copilot and pywrite here, and rough going. The UDP requirement is likely due to thread. If I recall correctly, the open thread library used to only have a UDP API. Yeah, maybe. That would make sense. They say that TCP is also supported, but I don't know when and how that gets established. Okay, so this is happening. That print is happening. So now the question is I'm on an exchange, and maybe I just say self protocol ID equals protocol ID protocol opcode is equal to opcode. Oh, come on. And then if application payload, actually I could just say sorry for the Twitch spam. I'm probably not logged in. It's been a while since I've had to moderate Twitch.
Back on the hunt. That's one for
it's
them.
playing something.
Could be the first one on the board for them too.
Why are you auto-playing?
Elimination there in the tree and keeps it moving.
I don't want to watch Fortnite. Jeez. That's so poor. How do you know I'm a millennial? I'm like, stop auto-playing. It's gonna do it again. All right. Warn. Ban. Goodbye. Sorry, distracted. Autoplay. Change my output. Go into my headphones. I don't actually think it's just you. I think there's actually 3 others. There's 4 people watching on Twitch, I think. It is going to be more responsive than YouTube, but YouTube's got the YouTube's got the subtitles, which I really like. Okay, so send message, and I think I just do self session send message. Header buffer, we're not gonna do that anymore. Hi lurkers. So let's see what it does now. Unsecured message context send, missing one required positional argument, application payload. Okay, so I don't want that. You know what? We could make application payload actually just like do the encode as well. So there are some questions coming in on Twitch also. Yeah, the care string stuff is coming in on Twitch chat. I have, I don't have it on screen, but I do have the restream chat off screen here as well. And the restream aggregates, like occasionally there's LinkedIn people and there's also Twitch chat that comes in from time to time too. So that, yeah, that's where that's coming from. Session send message. So now let's find our, where's my session? Unsecured session, header. This is just going to do message, and let's do print message dot encode into Does that make sense? I'm not sure that makes sense. So the thing that I'm thinking about right now is at what point do we go from this message object to the encoded bytes? And the thing I'm thinking about is the fact that it's the exchange's job to track resending something. But I also think, like, oh, am I over-optimizing? I'm probably over-optimizing. So I think that I think I'll just if we end up having to rebroadcast something, we'll just re-encode it, and that's fine. Because I think there is stuff that, like, this session context is gonna want to fill out in the message object. So I don't think we want, like, Exchange will hold on to the non-encoded version in case it needs to rebroadcast it. Or resend it. Although, message counter doesn't need to change. Yeah. Does the broadcast message always get responded to ACT, or can they be fire and forget? I'm not sure what you mean by broadcast message. There's a flag in security flags. In this message format, like, I think it's security flags. It could be message flags. Session type. Or maybe it's exchange protocol flags. R is reliable. So if you get something with the reliability flag, you shall indicate the message sender wishes to receive. They want an acknowledgement back. So if you don't have the R flag, then yeah, you don't need to manage this. We just need to keep track of the counters, IDs, and flags. Recomputing is often cheaper than storing in memory. Yeah, that's the other thing. We might get more interest on Twitch with a Python tag in software and game development category. I don't do a lot of Python. That's probably part of it. I'll try to remember that for next week. But yeah, usually I'm doing C. Okay. It's like hot in here. I'm trying to heat the whole air. Blow the cold air right on me. Sorry if it makes my audio worse. Hi, Timon. Okay, so this knows whether we're the initiator already. Message reception state. Oh, and I had this problem that there is the message counter that you use is not per unsecured session context. So maybe we need to even have a second layer. Don't know. This is I'm trying to get back to the point where I send a UDP packet to an address with all my bytes. It's just so complicated, and it's not clear to me, like separation of concerns stuff. And maybe I should take a look. Maybe I should take a look at the C structure, the C++ structure. It's probably worth doing next week, maybe, when I'm thinking about this. But I don't want to copy it either, because it's probably over-engineered there. Okay. Message flags. Only if the source node ID field is present. Destination node ID. Let's see. Here's like they do have these pretty easy. Okay, security processing of outgoing messages. Depicted graphically in the master color-coded convention. Is PDU encrypted and authenticated. Flags, session ID, security flags, message counter, maybe source ID, destination ID, extensions, encrypted message payload, and validation stuff. Session flags and source ID are plain text nonce fields. Plain text to be encrypted. To prepare a secure message for transmission with a given session ID, destination node ID, and security flags, the node shall perform the following steps. So I think we need to say, I assume that we need to set this. So message, oops, destination node ID is that. You know, maybe what we need to do is we need a message counter object. And then we can say, oh, here, unsecured session context, which they really treat as just like a data store. I'm the one that's adding like functions to it. I probably just say message counter, and then I can say, hey, I'm sending this message. If message.message counter is none. So if we filled it in before, we're not going to overwrite it. Next message counter. But I think what I'm thinking is that we just say message counter. because I don't think we need the whole. We just say, okay, message counter is message counter. And then we say, we could even make it an iterator. Should we make it an iterator? Next, self message counter is equal to okay, so now we have some work to do. This also is going to need to get an encrypted message counter. You probably talked about it previously, but what's the motivation to write a Matter implementation in Python versus pulling in a C++ implementation and wrapping it? One is it's a pain in the butt. It's got a ton of dependencies. It's written by people at big tech, and there's like kind of wild. But more seriously, being in Python means it's both more portable and not something that we need to bake in the firmware. So it's portable in that I can develop it on CPython and planning on getting it running on CircuitPython. And it's Python. It's more portable, and it doesn't need to be built into the software. And I can implement just the things I need. I don't need to do everything. Which is, I was quite surprised actually that Limor was on board for this, because I was like, I think like I got the C++ stuff working, but it's like a ton of dependencies and stuff. Why not? Like, I kind of just want to re-implement it. And Limor was like, yeah, I think so. Like, it's going to take weeks or months. And she's like, that's fine. I think this is a good project. I'm like, all right. So I'm just trying to like not get stuck and just every day plug away at it and make some progress. And I was kind of feeling like I didn't make enough progress this week, and then recounting everything I did since last week, I'm like, I think I made fine progress. Like, I'm just working through the layers, right? Like once I send a reply back, and then I like get the next message, now I'm like in negotiating the secure stuff. And then once I'm there, I'm like at the interaction model layer, and I don't know. Are there any constructs that you've already used in the CPython code that you know don't port into CircuitPython? So there are some of the MDNS APIs that I'm adding are not in CircuitPython. So we'll have to expand MDNS in CircuitPython. Jeff is already working on IPv6 support in CircuitPython, so like the socket stuff should be okay. I'm using more typing here than CircuitPython will care about, and it's going to be still quite large. But when I was talking to Limor about it, she's like, yeah, but like we can freeze it in. We can freeze it in if we really want to. If something is specifically for like Matter, like we can still freeze in the Python code, and that'll free up RAM. The other area I know we're going to have to do some work in the core of CircuitPython is cryptography. There's a lot of cryptography that I'm about to get into once I've got this communication going back and forth. It's like the very first response that I'm giving back is like, here's a seed, the seed number, here's my seed and the number of iterations to do. And so like this negotiation is going to be like starting to initialize some like cryptography stuff. And it seems like the de facto implementation for that is it's called cryptography in Python. It is not a small package. I will not implement all of it, but I intend on copying it. So there's going to be work there in terms of like implementing cryptography primitives in CircuitPython. That doesn't mean that doesn't mean I'm implementing the cryptography routines. It's just I'm going to be making this cryptography API that matches CPython and then implementing it using embed TLS or something. Some well-known C library that does it, which I haven't gotten to yet. I'd rather just prove it out. Yeah, CareString says cryptography package on PyPI is top-notch. Yep, that's my plan. I was Googling some of it, and like yeah. So we'll implement that in CircuitPython. Not the whole thing, but the bits that I end up using. TLS 1.3. So this is more like symmetric key cryptography and authentication stuff. That is chapter 3 in the spec. Cryptographic primitives that I have not read yet. So this is kind of in the vein of like, I'm doing things as I need them. I'm not gonna, I mean, I kind of like did my research already that some of these things I know that in like the cryptography module, I'll be able to do them, which is another reason to prototype or to start development on CPython, is that then we run the code in CircuitPython and say, oh, we need this particular package in cryptography that has this function, and we can add that to CircuitPython. That's kind of my job. And you know what? I think like adding cryptography support into CircuitPython that way would be great. So I think we're striking the right balance of like, we're going to enhance native CircuitPython to do primitives that we need for the Matter protocol, IPv6 cryptography stuff, NDNS features. Do that in the core, and then everything above that is Python. I mean, one thing that's nice about it is that it's not time sensitive. So, and this is something that it's not like performance sensitive. So, like you're not streaming video, you're not streaming audio, you're doing very small packets. And so one distinction is, I did this dev guide ages ago, but if you're on, if you look in the docs for CircuitPython, there's this design guide, and this was written a lot in the first kind of year of CircuitPython, like taking the philosophy, and it's amazing how much of this is still true. So like getters and setters, you like use a property if you're representing state. If you're doing an action, then it's a function. Exceptions and asserts, designed for compatibility with CPython. Here's how to document stuff. What was I thinking about? Adafruit register. Oh, maybe it's not here. Composition. Small libraries. Not doing that one. Maybe it's not here. Adding native mod. Maybe it is. Anyway, what I'm trying to say is that, yeah, CareString, feel free to ask questions. Happy to. One of the reasons to not implement something in Python is that you need like execution speed to be better, but that's actually not the case for Matter spec. I don't care how quickly it runs. So I'd rather have it in Python, I think. But I can accelerate decode, encode, and I can accelerate decryption and encryption using the cryptography hooks too. So yeah, that's kind of planning future work. CareString88 says, what's the difference between optional and nullable in the descriptors? Yes, I was confused by this too. And I'll show you in the spec. So, in the spec, not in encoding, but in here, qualifiers, nullable. It has to do with whether you have to encode it or not, I think. Right, so a nullable qualifier is used for these things, declares that a TLV null may be substituted for the value. Applying a nullable to a type is exactly the same as choice of with either the value or null, which I think of as like kind of like along Python's optional. However, they also have optional. Declares the field within a structure or field group is optional and may be omitted by the encoder. The optional qualifier may only appear on the name portion of the field defined within a structure or field group. It's distinct and both semantically and in terms of encoding from a field whose type has been declared nullable. The former may be omitted from the encoding altogether. The latter case, the field shall appear within the encoding, however, its value may be encoded as null. It is legal to declare a field that is both optional and nullable. That's perfectly like, it's just like, I get it, but like, what? Which is kind of like my whole experience with this stuff. It's like, I get it, but why? Like, and I think, so another role that I think we play at Adafruit is that we are curators. We kind of like take this big giant thing and then we strip it down to just the thing that's actually used. I think CircuitPython's benefited a lot from like early on the early days for USB. We like really focused on just like, it's going to be a keyboard, but it's going to be a standard class keyboard. It's going to be a mouse that works on the boot screen. It's going to be like a gamepad that works across as many things as it can work across. Like, we really focused, or mass storage device, in other words, we're going to be a mass storage device that works across everything. Like, we focused really hard on just like the stuff that works kind of more universally, which is also why I'm like, when I'm thinking of all the way to the like, when I'm thinking kind of the other end of like, what devices do we present examples for? I'm going to look at the list of like what Apple Home supports. Like, they list like, here's all the different device types of Matter devices that we actually support, right? And that's where we're all focused on, as the one, like the intersection of like the common Matter controllers. It is a very C-brain description standard. Yeah, it's all designed by committee for sure. Which is why, maybe it was Dan that asked me, like, why do you think you can re-implement it when, like, a group of 50 people have spent years coming up with a spec? And I said, a group of 50 people has a lot of overhead, a lot of committee meetings and emails back and forth and blah, blah, blah. Whereas, like, I'm just, like, you've seen my process. I'm like, okay, I have this packet. What am I doing? I'm gonna ignore the corner cases if I can, until they crop up. Okay. That was long-winded. I was making message counters into objects. So it's going to be a sibling to message reception state. Def init starting value. Next int index repr. I don't need that stuff. Hey, that's right. And it wraps. So now, where we start our message counters, Sessions manager. Oh yeah, this is fun too. So, actually this might be good. So if you look at the spec for message counters, some of them need to be preserved across resets and power outs. So if you look at message counters, they have this table. Global unencrypted message counter, lifetime unlimited, rollover allowed, non-volatile optional. Interesting. Global encrypted data for a group is mandatory, meaning you have to remember what number to start on. Checking counter, mandatory. And they also talk about like, oh, but you don't need to save the next message counter every time you increment it. You can say like, oh, I did 100, I did 100, I did 100. Or like, I'm getting one, let me write that I'm going to use the next chunk 100, and then if something happens and I restart and I start 100 ahead, that's fine. It's just pretty wild. I am really happy with not ChatGPT, Copilot. Copilot helps us a lot. I don't know exactly how I want to do this. I don't know how I want to structure like, hey, let's write it out. Because I'm kind of thinking, I mean, I could have separate files for everything, but I'm kind of thinking what I'm going to do is it's just going to be like some dictionary that gets slurped out off the disk, and then when I need to like checkpoint state, like non-volatile state, like it just goes into this one JSON file. The one thing I was thinking about that I may not want to do that way is the actual like encryption keys. I'm not planning on storing them in an encrypted way. I'm just going to put them on the disk. But I do want to put them on the disk in a standard format so that you can actually like see that it's a security key and stuff. I haven't gotten there yet. Okay, message counter. Unencrypted message counter. Which is funny. I have it being loaded, but I don't actually need to. And if I remember right, I think when you create them, you're supposed to do it randomly. That's okay. Oh yeah. All message counters shall be initialized using a random value using crypto DRBG length of 28 plus 1. Increase the difficulty of tracking traffic analysis attacks by making it harder to determine how long a particular session has been open. Well, maybe since we're doing message counter, we can make that equal none. If starting value is none. For 28 bits is 4 bytes of randomness, and we can do struct unpack starting value. We want to clear the top 2 bits. It's going to be least significant bit first. So we're going to say starting value of 3 and equals F. How will the cross restarts non-volatile memory be handled in CPython and CircuitPython? So right now, my plan is that I said you handle, when you create a CircuitMatter, this file is getting too large. when you create a CircuitMatter, you give it a state file name. So my plan right now is you just give it a JSON file, and it reads and writes it. And in CircuitPython, that can work too. One thing that's interesting is that you can actually run multiple nodes. Node is like the unit for like what it thinks of conceptually as a device, but it does say like, hey, by the way, you can actually have two nodes running on the same device. So by like kind of factoring that out, you could have this state file and that state file, and you could actually run two at the same time. You're answering the question while these questions are in the queue. I have a typo in the if statement. I'm not surprised. That's what running it is. It's probably because I actually typed it. No, I think, no. Okay, so I'm knocking out the top 4 bits of the top value. Set item is not defined on type bytes. Great. That's what I need. The reason that I'm doing this, so I could unpack the value and shift it 4, but I'm thinking ahead to CircuitPython. So maybe I shouldn't. Actually, maybe I shouldn't. In CircuitPython, you'll allocate if you're above 31 bits. But yeah, let's just do. I think it's going to be easier to read if we just do starting value. Shift by 4. Okay, so that gives us our 28, and then it actually says +1, right? It doesn't really matter. Why? I don't know why. Message counters, length of 28, random number, +1. I like how Copilot picks up on typos like that and suggests subsequent code without the typo. Oh yeah, I'm like totally sold on Copilot. That hasn't changed. It is quite handy. I've stopped getting distracted trying to implement it myself though, or run a local one. All right, let's see. Where are we going? Message object has no attribute encode. Did you mean decode? No, I didn't, but you know what? I meant encode into. 345. And I'm just going to say buff equals byte array 1280. And I actually know 1280 is the maximum length of a single packet. And then encode into probably wants to. Should it return a memory view? Or n bytes, and then we can memory view it. I love memory views. Because they don't actually copy data. They let you trim it down. So you have to pay the cost of a new object for the memory view, but it doesn't copy the big buffer. It shares the underlying buffer. Okay, so this is going to print out the encoded version. Bird argument is not an integer. Where have I seen that before? I had this error earlier today. 469. All right, we got about 10 minutes left if folks have any more questions. Now is the time. I'm going to print all this stuff off. And I also know that I'm going to return offset. None. We have some nuns. That would do it. So exchange flags is set, but protocol opcode and exchange ID are not set. And we are in process packet send 754. What? You know what? I think there might be a mode where I can see file structure. Send protocol ID. Protocol opcode. But I needed exchange ID, didn't I? Is it exchange ID on it? Oh, I'm setting it to... I'm setting the wrong thing. Message. Message. This is probably a copilot error. Message object has no attribute pending acknowledgement and encode into 473. That's right. I need to say if what's it called? Acknowledge message counter? I think it's okay for me to not clear it. I'm not, one thing I could do here is I could do struct calc size 4. I wonder what struct packed into returns. I wonder if it tells me how much it packed. What does pack into return? Ah. It doesn't return anything. Darn. Okay. Pop from an empty list. I think this is what I want. It's just not. Packs into the buffer that's passed in. Yeah, but it doesn't tell me how much it packed. I was hoping it was kind of like going to tell me. Like, oh, you did an I. It's 4 bytes long. It's the equivalent of calc size. Sorry. Sorry again. I don't have a sneeze button. Maybe I need to make one. All right. So I think what I'm going to do is stop here. I'm getting lost. I got to figure out how to structure this better. Or at least navigate this better. But where's my print? Encode into there we go. Memory views don't print out well for some reason. Actually, you know what? We could do it as hex. I'm not sure CircuitPython has hex either, but it's super handy. So now when I run it, I'm getting the length and then the encoded packet. What I'm going to do now is I'm going to check it in because I'm about to stop working for the weekend. And so let's just get it pushed. That's kind of how I back up my work, is just pushing it. Okay, so here's Sublime Merge. And this is all the stuff that I've changed since I committed it last. There's the message counter class that we added. Exchanges now know their session, and they call session send. Send standalone, which we're not actually calling yet, so I'm going to have to add that. Correcting the section reference, which threw me off earlier today. Message counter gets passed in here. Messages are now like better structured into decode and encode. The little ending gets me. The values don't read left to right nicely. Yeah, most Cortex M's are little endians, so that's part of it too. Thanks, Timon. Have a good weekend too. You too, Tyeth. I'm not stopping yet. Because I gotta run the pre-commit stuff. And it might complain at me a little bit. We'll see. Sure, I'll include the new recorded packets. Okay. I might have to do my pre-commit and work on sending a message. Yeah, like I said. All right. I'm just going to switch away here while I grab my GPG key to sign. Okay, we have a commit. That went faster than I thought. Hit push Adafruit main. Oh. Carestring says, nice, I'll fetch and rebase my work in progress. Awesome. Thank you so much for the help. Just pushed, and yeah, I actually, Carestring, I did have to rebase some of my changes on your stuff too, so it's all good. So you should be up to date with what I've done. And thanks for the help. I really appreciate it. So thank you, everybody. This has been another Deep Dive with Scott. I hope you have a great weekend. You like my new shirt I got for my birthday. My wife got me a cool Henry shirt, local artist. If you want to support me, go to adafruit.com, purchase hardware there. At some point, we'll get it acting as a Matter device, maybe a month or two from now. We'll see. And yeah, check out CircuitPython if you haven't. It's really meant to be easy to get going. You can go to circuitpython.org if you want to know more about that. Deep dives happen here, 2 p.m. Pacific on Fridays normally for about 2 hours. Foamy Guy fills in for me if I'm out. Happy belated birthday, yeah. My birthday is the 15th, so on Monday. If you want to join the Discord here, the URL is adafru.it/discord. You want to follow along, it's the github.com/adafruit/CircuitMatter. I think that's it. Preemptive thank you to DCD for timecodes. They usually do that for me. And we'll do a little window cam and get out of here. Next week I should be around, I think. But the week after I'm gone. I am gone the 2nd. Yeah, so I think next week I'll be around, and the week after I'm gone, and I haven't checked with Tim yet. So, happy birthday, Hams Labs. Have a great weekend, everybody. I'll see you